This week we're going to look at trigonometric graphs. So graphing these is very similar to everything else you've ever graphed. All of the transformations work in the same way. It's just that we're using trig functions. So the first thing you need to know is that sine and cosine are periodic. So if you look at the unit circle, it's a circle. So if you spin around the circle, you come back to your original position, and then it just repeats if you were just to go around the circle. So that's the same thing for sine and cosine. Sine is the y value of the terminal point on the unit circle, and cosine is the x value of the terminal point on the unit circle. So these things repeat every 2 pi. So here is a graph of sine, y equals sine t, the red line. And you can see it's divided into 4 quadrants, just like the unit circle. Quadrant 1 is from 0 to pi over 2, or 90 degrees. Pi over 2 to pi is the second quadrant, which is another 90 degrees. So each of these represents 90 degrees, and 2 pi represents 360 degrees. So you can see that it's, if you can envision that with the circle, it helps. So to help you though with that, I will pull up an animation. And this is with Desmos, and this is a really good animation to help understand what you're looking at. So the unit circle has a radius of 1. So the highest value on the unit circle is 1, and the lowest value on the unit circle is -1. So sine is represented by the y-coordinate of the terminal point on the unit circle. So if I turn on the sine animation right here, I'm going to start it when it hits 0, right there. Oop. You can see that what's being graphed right now is the y-coordinate on the unit circle, which is sine. And if I just zoom out, you can see that this repeats every 2 pi. So at 4 pi, it should go right through the axis again. And then it just repeats. So sine and cosine, when you graph them on an xy axis, look like this. So this is sine, this is the y-coordinate. Now if I turn that off and turn on cosine, let's wait till that's reset. There we go. Now what's happening is that it's graphing the x-coordinate of the terminal point on the unit circle. So again, it repeats every 2 pi. It just starts in a different place. So if I turn both sine and cosine on together, it gets a little confusing, but you can see there it's graphing the same shape. It's just that they're out of phase. So they're not exactly aligned, and we'll talk about that a little bit later. So I'm going to go back to the notes. And here we are. Okay, so y equals sine t is here, and we have cosine, which is right there. So both of these graphs are the parent functions, so we're going to use these to graph transformations on sine and cosine. Okay, so transformations of sine and cosine. So I wrote all this out. Keep in mind, these variables might be different in other instances. I need to adjust this one actually. It should be a K. Let's do that. Okay, so A, K, B, and C. Some books use these same variable letters and others use different ones. So the letter doesn't matter, it's the position in the expression that matters. So right here, we have the key for that. So y equals a sine of k, parentheses, x minus b plus c. And cosine is the same, y equals a cosine k of x minus b plus c. So the absolute value of a is your amplitude. So this is how high or low it goes. It's basically distance from the center of the graph. Period is going to be 2 pi divided by k. So k is that number outside the parentheses, and that affects the period. The phase shift is the letter b. So notice we have x minus b in those two expressions. So phase shift is really left-right shift. We just call it phase shift because we're working with sine waves. And the vertical shift, up or down, is the c at the end. So let's just work with 1. And what I always do is have these things written on the side. So the absolute value of a is, the period is, phase shift is, vertical shift is. And this helps me keep track of what I'm doing and what I need to graph this. So this first one, notice that the 1 is in front, but that's actually my vertical shift. So the expression is y equals 1 plus 2 cosine x. The 1 is my vertical shift. The 2 would represent my amplitude when I take the absolute value of it. But since it's positive, it just stays 2. The k value, so the period is going to be found by taking 2 pi divided by k. And the k value here, notice there's no number in front of x, so we assume it's 1. So 2 pi over 1 is the period. So 2 pi. And there is no phase shift, so I'm going to start with phase shift of 0. With all of these graphs, the thing that I always have done first is start with the vertical shift. So the vertical shift is 1. So what I'm going to do is draw this dashed line to represent that. Okay, so I'm done with the vertical shift. The period is 2 pi, so what I'll do is go on the axis and I'll just put 2 pi here, pi in the middle, and we can have all 4 quadrants if you want. Pi over 2 and then 3 pi over 2. And this is a cosine, so I know cosine starts at its highest point, and the amplitude is 2. So the amplitude is the distance from the center of the graph, and the center of the graph here is 1. So I'm going to start 2 above that, so I'm going to start at 3. So on the y-axis, I have an intercept of 3. And if the period is 2 pi, that means it's going to return to its original position at the end of that cycle. So at 2 pi, I'll also have a point at 3. In the middle of those, so directly with cosine between the beginning and the end, you're going to have the graph at its lowest point. So we're going to be 2 units below the midline because the amplitude is 2, so it's going to be 2 above and 2 below. So in the middle at pi, there will go have a point at, sorry, I put that a little too high. It's going to be 2 below the line y equals 1, so this will be at -1. And that's really all there is to it because we're just sketching these. So I'm going to take my pen and hopefully catch all those points just like that. So that is the graph of y equals 1 plus 2 cosine x. Okay, so now we have one with a phase shift. And so this, each of these examples doesn't have everything thrown in because might be too confusing at first, so we're starting small. So y equals 3 sine of x minus pi. So we'll just go through all of this. The amplitude is going to be 3. The period, since k, there's no k here, so we don't, or there's no number in front of x outside of the parentheses, so we assume it's 1. So the period is going to be 2 pi over 1, just like the last one. So that's 2 pi. The phase shift, this does have a phase shift. So x minus pi tells us the phase shift is pi. And there is no vertical shift, so we'll say it's 0. So again, I always start with that vertical shift, and there isn't one, but I'm still going to draw this dashed line on the axis. Okay, so there is a phase shift. So what I'm going to do is fix the axis. So I have, normally we would have pi over 2, pi, 3 pi over 2, and 2 pi. And then we're going to have one more pi over 2 after that. Or no, this needs to shift pi, so we'll talk about that in a second. Move that a little bit. I'm going to need that space. Okay, so this has an amplitude of 3 and a phase shift of pi. So it will start at pi. It's a sine wave. So this one starts on its midline. So sine will always start on the middle line. So at pi, I will have a point. And it's going to repeat every 2 pi. So the question is then, what is pi plus 2 pi? And so that would be 3 pi. Okay, so it's going to start at pi. It has a period of 2 pi, so it'll repeat its cycle after 2 pi. So pi plus 2 pi is 3 pi. So we have another dot on 3 pi. Okay, directly in the middle, sine goes through its midline again. So at 2 pi, which is halfway between pi and 3 pi, is the other point. This has an amplitude of 3. So between its first point and its midpoint, it will be at 3. So its high point will be y equals 3 at 3 pi over 2. And its low point is going to be 3 below that between 2 pi and 3 pi. And I'm going to talk about how to get those values as soon as I graph this. So you can see with those 5 points, I can draw my line. And that's an okay sine wave. Again, these are sketches, so they don't have to be perfect. And this is what I'm going to show you. So on the scale here, so I want to get a point at its lowest point there. I want to get that value on the x-axis. So every unit, so the first one's worth pi over 2. Great. And in green here, I'm going to write the unsimplified fractions, because when I first learned this and somebody showed me that we could just use unsimplified fractions, it helped a lot. So if I have 1 pi over 2, okay, that's pi over 2. If I have 2 pi over 2, that's just equal to pi. 3 pi over 2, 4 pi over 2, and what's the next one? 5 pi over 2. Okay, and this last one at 3 pi would be 6 pi over 2. So if you're ever wondering how to figure out what those values are on the x-axis, just start at the first one and count by 1, because it's really just 1, 2, 3, 4, 5, 6, all over the same denominator. So this value on the x-axis is at 5 pi over 2, and that's directly between 2 pi and 3 pi. And that makes sense, because 5 divided by 2 is 2.5, so it's directly between those. Okay, so we have one here. Y equals 3/4 cosine of 2x minus 2 pi over 3. Okay, so let's pull all these parts out first. So I'm going to start with the vertical shift because it is 0. And then let's do the amplitude. So 3/4, pretty easy. The period. First thing I have to do is actually divide out the 2. So 3/4 cosine of 2x minus 2 pi over 3. I need to divide both of these by 2. So I would have 3/4 times cosine of 2, and then in parentheses I'll have x minus pi over 3. So you have to take that k, or the coefficient of x, you need to take it out of the parentheses first to see what the phase shift is. So now we know that the period is going to be 2 pi over 2, because k is 2 here. And so the period's just pi. And the phase shift is pi over 3. So I'm going to graph this. I'm going to start with the vertical shift again, which is on the axis, because it's 0. This is a cosine wave, so it starts at its highest point. Its phase shift is pi over 3, so it will start at pi over 3. Its period is pi. So we need to figure out where it's going to land, because pi over 3, if it starts there, I have to add pi to that. So I'll do that math right here. Pi over 3 plus pi is the same thing as pi over 3 plus 3 pi over pi, or 3 pi over 3, which is 4 pi over 3. Okay, and I'm going to move that, but I'll leave it there so you can stare at that or write it down, figure that out. So that tells me that the ending value is going to be 4 pi over 3. Okay, so then we're going to have something between it, and we'll get those values in a second. So this is a cosine value. Its amplitude is 3/4. I will just call this 1 at the top so I can use 3 of those dots. So it's going to start at y equals 1 at pi over 3. It will repeat at 4 pi over 3, so that also has a dot. And its lowest point happens between those two. And then I can just connect it. Okay. So far, that is what our function would look like. And we would need to find out what those, what each division is worth. And this is where it gets a little tricky. When you're doing these problems, I actually prefer that you just do the first, middle, and last one, although you should know how to do all of them. So let's look at this. We have pi over 3, and it ends at 4 pi over 3. So this whole distance would be pi between those two. So this is a distance of pi. So what we're going to have to do is divide pi into fourths to do this. Okay, so it's going to be pi over 3 plus, this is going to be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And what we have to do is say, well, pi over 3 plus pi over 4. We have to figure that out to get the middle one. And then we have to take whatever that number is and add it to the next one. So this gets really messy. That's why I don't expect you to do more than just the first, middle, and last. So if you look at the green line, in the middle is 2 pi over 4. So that means I have to add that to pi over 3 to get my middle value. So I'll have pi over 3 plus 2 pi over 4, and that will be my middle value. So I will, use a common denominator. So I'll have 4 pi over 12 plus 6 pi over 12. That will be 10 pi over 12, which if you divide both of those by 2, you get 5 pi over 6. So this middle value is 5 pi over 6.